Prove there is a root. All right. First of all, I hope everybody recognizes that a root means you got to prove it's 0. And that's what it says here. You got equation equals 0. If we're going to use IVT, we need a function. This is not a big leap. So we're going to say, I want to prove this has a 0. Everybody, what's the one fact you got to do right away with IVT? Continuous. You have to say this is continuous or you're in deep trouble. But everyone, of course, this is an easy one because it's a polynomial. So the first thing I say, hey, this is continuous because, I'll abbreviate it, it's a polynomial. And the cool part is we know the domain's all reals, but we don't even need that. We just know it's continuous everywhere, all right? So we can definitely use IVT anywhere on it, okay? In its domain, of all reals. If I want to prove now, I didn't give you what 2 interval points. You have to pick the interval points. I would hope you picked 0. I would hope you'd glance, put 0 in at this point in our the year and say, okay, it's going to be -5. So the first thing you do is I say, hey, I'll go f of 0 is -5. I don't know, how about 2? I mean, you can pick a much higher number, I suppose. Like f of 2 is something that's easy. 16 minus 4 is 12. Plus 6 is 18. Is it 13? Yeah, I didn't make a math mistake. Awesome. All right, at this point, whether you're struggling with IVT or not, we'll talk about how to write it. You should be able to visualize what we're talking about. I'm going to change colors for this because you don't need this for the proof. But everybody, at 0, it's -5. At 2, it is 13. Right? Boom, boom. And it's continuous. So if I'm going to go between these two, I don't know what this looks like, right? But if it's continuous, somewhere in between, there is a value of C, at least 1, maybe 2, right? But at least once. At least once. I don't know if this does an S-curve, but all I have to do now is state this. So we can go by. So now it's, and again, we've got to spell squeeze, but we can abbreviate IVT. Don't ask me why, it's just what we can do, right? So by IVT, since f of x is continuous, right? You have to say it's continuous. I'm going to have to work around state IVT. Since f of x is continuous, and what? And our value is between the two y values, right? The y value we desire, 0, is between -5 and 13 this time, and I can use whatever notation I want, so I use function notation. Then, f sub c equals 0. But you got to do one more fact. This is the one that you guys often forget. You got to tell me where c is. Where's c this time? Between 0 and 2. Such that, I use like, and I learned it as such that where, I don't care what words you use there, such that where, such that c is between 0 and 2.
What is c?
C is the x value. C is the x value. So you see how I picked the x value 0 to 2? C fits between. And we are proving up here, right here, thought process, you don't need this. We were trying to prove that there was an f of c equals 0. And we did. And we know where c is. It's between 0 and 2. All right? Stating IVT. I go down for the video real fast. Boy, the board is being finicky. Suppose that f is continuous, right? On the closed interval a to b. Let n be a number between f of a and f of b. And it says where f of a doesn't equal f of b in these textbooks. We've talked about this in my class. What do I always say? That it has to be between, right? You can't be between if the values are the same. I teach it a little differently. Then there exists c in a to b, where f of c equals n. Guys, here's the picture, right? Here's the picture. We've drawn this picture a lot of times, all right? If I had any public embarrassment, I'd re-record this, but I have no public embarrassment on these videos. So we're going to live with the stutters, all right? Everybody, you should be able to state this theorem too, right? If you're going to use it, you got to be able. And everybody on a test, if you have to make the picture, that's fine. You know, I don't need I don't recommend memorizing, but if you need to memorize. Cut.